Hello everyone. Welcome to the lecture class of Structural Design and Drawing. In this class, we will be discussing about Unit 2, Flat Slab. Okay, so before getting into it, we'll see what is flat slab and where it is used and what are the design requirements of flat slab. Is that clear? And how far it is differ from normal slab. So flat slab in general, it is also a reinforced concrete slab, but it is directly supported on column. Usually, where does the slab rest? Its slab rests on the beam, and beam will rest on the column. Whereas in flat slab, it will directly rest on column without the agency of beam or the girder. That is the speciality of flat slab. Okay, so the proper definition would be a flat slab is defined as a one side or two side supported system with a shear load of slab being concentrated on a column or a square slab. Okay, so that square slab we call it as a drop panel. Okay, so I'll show what is drop panel in the picture. Okay, so the usual size or span of the flat slab is 5 to 9 meter. A thin flat slab are preferred solution for the construction of inside the concrete frame building, where square or near a square grid. Okay, so if you see the application part, it is used in theaters, factories, mills, and shopping malls, and etc. Okay. So in this picture, you can observe slab that is directly resting on a column. There is no beam member is being present. Okay. There are different types of flat slab available. We have slab directly resting on column, slab resting on a small square slab. After that, it rests on a column. Okay, this we called a small square slab is nothing but a drop panel. Okay, third type we have the head on the column, and that is called as column head. The slab directly rests on column head and then to the column. And fourth one is a combination of column head and the column. That is the drop panel. Okay, so the next slide, I show a real-time picture of all the types. Okay, first picture, you can see the column without any directly resting on the column. And second picture, you have a drop panel in between slab and the column. Okay, and the third picture, you have square column head here. Okay, and fourth one, we have both drop panel and column head. If we consider drop panel, it plays a very significant role in increasing the overall capacity or the sturdiness of the floor system. So that's why we provide drop panel and column head. Okay, thereby it enhances the boosting capacity of the construction when subject to the vertical load. And the usage of components of flat slab, we have why we are using column head and why we are using drop panel. Okay. So in usage of column head, it increases the shear strength of the slab, whereas drop panel also increases the shear strength of the slab. And second point is the moment and slab is being reduced by the effective clear span. Okay, by using drop panel, it increases the negative moment capacity of the slab and enhances the stiffness of the slab. So thereby the deflection is also get reduced. So next part is a benefit of flat slab. So what are the benefits of normal RC slab? Then flat slab is there is a flexibility in room layout, right? So if you see the flexibility of room layout, you can adopt any of the size here. Okay. If the client changes the plan in the interior and he wanted the shape to be circular, or it can be an octagonal, it create a difficulty in the construction of beam. Okay, so in that kind of situation, a perfect choice would be a flat slab, so that you can flat slab, since the beam is constructed in the absence of beam, so flat slab is provided in the complication of your uh, if there is a complication of flexibility of the building. Okay. Second type is saving in building height. Okay, you can see from the picture here. If the beam is provided, there is a decrease in height. If the beam is absent, there is an increase in height. Okay. Third one is the shorter construction time, because it is the thickness is very much less. So the requirement of for construction time is also get reduced. And the third one is the prefabricated welded mesh is used so that it results in shorter construction time as well as. Is it clear? So these are the benefits of using flat slab in various areas. And main thing or concept that has to be understood in is flat slab is punching shear. Okay, so it is considered to be more critical because the load is concentrated at one point. Okay, where it is concentrated, its load is concentrated on column. Okay, so it is very much similar to flat plate design around the column. Okay, so instead of using a thicker section, a shear reinforcement is provided in a form of shear head or shear stud or a stirrup. Okay, in general, to counteract shear stress, we provide stirrups. Okay, in flat slab, to avoid punching shear, we provide shear reinforcement in form of shear head, shear stud or stirrups. So in the picture, you can see it as a shear studs are used. For the calculation of design purpose, we separate the panel into two strips. One is column strip and other one is middle strip. Okay, so this is the entire slab. So we divide that into a panel. Okay, to reduce the calculation part, to reduce it, the calculation part easy. Okay, so the area around the column we call it as column strip, and the left out area between two columns we call it as middle strip. Okay, so in column strip width is considered to be a 0.25 L or 0.25 L2, whichever is less we consider as column strip. And the remaining portion which is bounded by column strip is called as middle strip. Is it clear? So this is given in your IS 456 portal provision. So this is the portal provision suggest the clause number is 31.2. That is the thickness of the flat slab. So to determine the thickness of the flat slab, there is a thumb rule is followed. It is considered based on the span to depth ratio. To find out the span to depth ratio, you can refer clause 23.2. Okay, so 40 is if it is mild steel, and 32 for it is high yield steel bars. Okay, and second is for slab with drop, the effective span is governed by the multiplying factor 0.9. Okay, so you will multiply 40 into 0.9, 32 into 0.9 if you are designing slab with the drop. Okay, and the other purpose, if it is for longer span shall be considered. And the minimum thickness followed is to be 125. It should not be less than 125 mm. And the drop requirement is given in the clause 31.2.2. Okay, so drop provided shall be rectangular in plan, have a length at each in direction not less than 1/3 of the panel length in that direction. Okay, and the minimum thickness of the drop is 1/4 of the slab thickness or 100 mm. And the third part is the column head. When the head is provided, the portion of column head which lies within the larger right circular cone or pyramid should have an angle of 90 degree, included entirely with the outline of the column. So for bending moment and analysis of method, we use either direct design method or equivalent frame method for slab. And direct design method have some limitations, and the limitations are listed below. Okay, so in limitation, if you see it is a minimum of 3 span continuous can be adopted. The panel shall be rectangular and the ratio for longer to shorter span shall not be greater than 2 value. And the permissible offset of column to be maximum of 10% in the span, because offset of the column should not be going more than 10%. And successive plan in each direction shall not differ more than 1/3 of the longest span. All these limitations are mentioned in IS 456 codal provision. So you can refer it for the further clarification. And the design live load shall not exceed more 3 times the design dead load. So in this class, we have discussed in detail about what is flat slab, what are the types of flat slab, and what would be the benefits of flat slab, and what are the design considerations that are to be considered while designing flat slab. Okay, so some of the codal provisions also has been discussed in this class, and we'll see in the next class. Thank you.